we're recording. So, this video is a quick recap of the final for those of you that need it. This is not a mandatory video. If you're fine with the final, or you're not worried about how you did, or you already understand the mistakes that you may have made, then you don't need to watch this video. I'm going to first go over, I've got the circuit that's the bad one on the board already, and I'm going to go over the questions first, though, real quickly. Actually, no, I'm going to do the circuit first, because I'm going to want to use the board to do a couple of the questions. So, we had a series circuit, we had a parallel circuit. The series circuit and the parallel circuit, everybody seemed to do fine with, which gives me great hope that you guys do understand what's going on. It's just when you had to figure out which part of those circuits, which part of this circuit was series and which was parallel, sorting that out, some of you had some issues with that. And there was one issue in particular that people had that I want to go over really quickly. Remember that a series circuit is a voltage divider. So the series parts of this circuit, and this again is circuit 3, and it's the one that's got a series resistor in series with a parallel combination of two resistors. And what I do is I solve those two resistors for their equivalent resistance, and I turn it into a series circuit, at which point I'll have a voltage divider. I'll have some voltage here, and I'll have some voltage here. And the trick is to take that voltage that I've got here on this equivalent resistor, which is really these two resistors, it's R2 and 3, solve that voltage, put that voltage up here and say, aha, in parallel, these have the same voltage as each other, whichever I solve for this. Now, they don't have the same voltage as the source because they're not in parallel with the source. They're in series with another resistor and the source in parallel with each other. So let's go ahead and quickly solve this guy. So I've got 60 ohms, 60 ohms, and 60 ohms. So the first thing I have to do is I have to take these two. The only thing I can do at this point, the only step I have, sometimes you have a problem where you can attack it from several different directions. But really the only place that I can start on this circuit is to say, well, what is 60 and 60 in parallel? These two are in a world by themselves, in my mind, right now, and I'm going to make them into one resistor. Well, I can go ahead and reciprocate them. 1 over 60 plus 1 over 60 equals some number that I then reciprocate again, and I get the R total for these two in parallel. But I also know the cheat method is, if I have two equal value resistors in parallel, I divide by 2, because there's two of them. 60 divided by 2 is 30. So I'm going to go ahead and fill that in over here. I have 30 volts, and I have 60 volts. Now I can solve for my total resistance. RT, obviously, is 60 plus 30 is 90 ohms. If I have my ohms and I have my voltage, I can solve my current for the whole thing. Now, I'm solving the current here, right? So, I equals E over R, in this case, 90, because I'm doing the whole thing volts, over 90 ohms. Easiest math on the planet, I get 1 amp. Now, that 1 amp travels here, goes through this resistor, and it goes through these two resistors in parallel. But wait, it doesn't all go through either one of those resistors. It gets to this node up here, because remember, this is just another way to model these. It gets to here and it has to split. This up here is a current divider. But we're still working on the voltage divider to figure out what the voltage is of that before we can even start to solve that. So if I've got 1 amp going here, I've got 1 amp through that resistor, and I've got 1 amp through this modeled two resistors equivalent resistance. So I'm going to solve the voltage in each one of those with Ohm's law. Now I could also do my the formula that you may have used from the book, the ratios, because I know that the bigger resistance is going to drop proportionally that much more of the voltage drop. So it's going to have 60/90ths, or 6/9, or 2/3 of the voltage, if I want to go through that in my head. So 2/3 of 90 is obviously going to be 60 volts. And this guy will drop 30/90ths, or 1/3 of 90, which would be 30 volts. But let's solve it with Ohm's law instead. So Ohm's law says that E equals I times R. And in this case, that's going to be my 1 amp times, in this one, 60 is 60 volts. Boom, I've got 60 volts there. I can go ahead and apply that up here. The E at R1 is 60 volts. Now, I'm going to solve this one the same way. E equals I times R. E equals 1 amp, because this again is my equivalent, 1 amp times 30 ohms, which is my equivalent resistance, and I'm going to get my voltage here across that, equals 30 volts. So that 30 volts lives right here. I can go ahead and put that 30 volts up here. Again, rules of parallel circuits, the voltage is the same across these two. If I've solved the voltage across the equivalent resistance of parallel resistors, I can go ahead and put that voltage up here. So I've got 30 volts drop here, I've got 30 volts dropped here. And you might say, well, how does that work for Kirchhoff's? How does that work for me being able to say, I'm going around the circle and dropping all my volts? Well, remember, we only take one path when we do Kirchhoff's. So Kirchhoff's takes one loop, and I've got 60 volt drop and a 30 volt drop if I use that route to get my whole 90. Or I've got a 60 volt drop, I go all the way out here to this part of the loop, and a 30 volt drop, that's 90. Either way, Kirchhoff works. So now that I've solved my voltage at these, and that was the trick that a lot of people got wrong. A lot of people went ahead and solved their current here using all 90 volts. And what they got was like 1.5 amps here and 1.5 amps here. Just thinking of that, that doesn't make any sense because I've got 1 amp here. How could my 1 amp get to this point and go 1.5 amps and 1.5 amps suddenly, miraculously, turn into 3 amps? If we could do that, we've solved the world's energy crisis. Right now we don't have an energy crisis, we've got a COVID crisis. But you understand what I'm saying. I cannot create more current. Every electron that goes into that node must leave it, and no more than have entered that node can leave it either. I can't create electrons here. I can't create more current than I've got going in. So when I solve this guy with my volts over here, now remember, when I'm applying that individually, I need to use the individual resistance. And my current formula from Ohm's law is I equals E over R. And in this case, my E is the voltage across these resistors, 30 volts, divided by R, and my R has to be my individual resistors. I had a lot of people essentially do the same thing wrong, but do it in different ways. Some people applied 90 up here, some people applied 30 down here with the 90. So anyways, I got to go 30 over 60. 30 over 60 is going to be 0.5 amps, and that makes sense. If I have 1 amp going in, I've got 0.5 amp going that way, I've got 0.5 amp going that way, rejoining their forces down here to complete the whole circuit with 1 amp. So 1 amp going out, 0.5 amp going each direction and back. I asked you guys to solve power. A couple of people either didn't or forgot how, or I'm not sure. But remember, power is easy. It's that other circle. P-I-E. Easy as pie, right? To solve power, I just multiply my current times my volts. So at this resistor, I'm going to multiply my 1 amp times my 60 volts. And I drew that poorly. 1 amp times 60 volts is going to be 60 watts. I've got 0.5 amp and I've got 30 volts here. So 0.5 amp times 30 volts is going to be 15 watts. 0.5 amp times 30 is going to be 15 watts. So there you go. Now I could get my total power, add these up. 15 and 15 is 30. 30 and 60 is 90 watts total. And that checks out because my total circuit has 90 volts and 1 amp. So if I use my whole circuit to figure out my total power, I'm going to have P equals I times E. I is 1 amp. And E is 90 volts. 1 times 90 is 90. So that was that particular problem that a lot of you had problems on. I'm not going to go over the series and parallel just because I don't have time tonight. I've got another video to make for you going into next term still after this. I do want to go over the questions really quickly though and tell you what you did right and what you did wrong. So the first question, I don't know if I'm in focus because I've got the board in focus right back there. Kirchhoff's voltage law applies to, if it's Kirchhoff's voltage law, it has to be series circuits, right? Wake up, my computer just died on me. It always has the best timing. Pretty soon the lights will go out too. So Kirchhoff's voltage law applies to series circuits because I can add all the voltage drops in series. Kirchhoff's current law applies to parallel circuits. So the correct answer with that was series. Can you have voltage without current? Certainly I can have voltage without current if I don't have any closed circuits, if I don't have any loops, if I don't have any loads that are turned on. I can have the voltage potential, the pressure, but I don't have a complete circuit so no current is flowing. I can't have current without voltage. Most all of you got that right. Pythagoras' theorem, which side is the hypotenuse? The hypotenuse is C. It's always C. That's the only way that formula works. So you just have to memorize that. If sides C and A are known in a 90-degree triangle, what's the formula to solve for B? Now, some of you just gave me a squared plus b squared equals c squared, which is right, but I'd have to do the math. And I was asking you to do the algebraic gymnastics to solve for b. Some of you, a lot of you, solve for b squared. You told me, well, b squared equals c squared minus a squared, which again is correct, but how do I solve for b then? So the correct answer to that was b equals, and usually we use the lower case, I'm not sure why in this formula, b equals the square root of a squared minus, excuse me, I did that wrong, didn't I? C squared hypotenuse minus a squared. That's always going to be the formula. I wanted you to solve it all the way to b. If you have b squared equals c squared minus a squared, I still have a step to do. I still have to say, well, then I got to put the radical on both of those. And I have to pull those numbers out of the radical. Square root of b squared is b. So these are some. A couple of you, when you solved your Pythagorean, we'll go over that actual circuit. When you, no, we're not going to go over that circuit. When you solved Pythagorean, yeah, I should go over that. When you solved Pythagorean, you didn't use your square root. So let's quickly, I'm going to erase this. Actually, I'm going to go through the rest of the questions. I don't even know what I'm doing. What's the equivalent resistance of two 20 ohm resistors in series? Okay, I'm going to erase this, so take a screenshot. What is the equivalent resistance of, and some of you gave me two answers, and I was fine with that because the way I asked it, it didn't make sense. But what I was asking was let's see here. What is the equivalent resistance of two 20 ohm resistors in series, both together in parallel with a 40 ohm resistor? So this is what I meant. Here's what I've got. I've got two 20 ohms in series with each other in parallel with a 40. So I've got 20 ohms, and 40 ohms. Well, 20 and 20 is 40 in series. I can add those right up. Boom. So now I've got a circuit that looks like this, or a pair of resistors that looks like this. I've solved 20 and 20 is 40 and 40, and I know that two resistors in parallel, you can just divide by the number of resistors. I could use the reciprocal. I could go ahead and go 1 over 40 plus 1 over 40, 1 over that, and either way, I'm going to get 20 ohms. So 20 ohms was the answer to that question, and that's why. I didn't take off much if you got that wrong or if you got it close. This was pretty much just for me to see where you guys were. A blank is a voltage-sensitive equipment. That's a capacitor. A blank resists a change in current. That's an inductor. An inductor is a current-sensitive component. A capacitor is a voltage-sensitive component. And that's going to become important. A series circuit with 3 equal value resistors is connected to a 90-volt power supply. What does the voltage drop across the first resistor? You don't need to know what the values are for these resistors. If I have 3 equal resistors in series with a 90-volt source and nothing else, then each one of those equal value resistors is going to drop an equal value of voltage. And if I have to drop all the voltage to go through the circuit, I have to drop all 90 volts. I've got 3 resistors, divided 90 by 3, and I have 30 volts. And most all of you got that correctly. And that's good. That's a really good thing to be able to see because I don't necessarily need values and numbers to solve a circuit. Parallel circuit with 2 loads of unequal resistance is connected to a voltage supply. Key here is it's a parallel circuit, 2 loads, unequal resistance. I'm always going to have more current at the lower resistance. So the correct answer of this is which will have the greater current flow, the smaller resistance will have the greater current flow. Because the two are equal sides of each other. One is this, it's the difference between conductance and resistance. As resistance goes up, conductance goes down. As resistance goes down, conductance goes up. Conductance is what allows current to flow. It's the inverse of resistance. In the same parallel circuit, which load will have the greater voltage drop? Well, they're parallel. So there isn't a greater or a lesser. They have the same voltage drop. And most of you caught that one too. So I'm happy about that. I'm going to go over that one Pythagorean question really quick, and we're going to do the Pythagorean. So if you're good on your Pythagorean, you can end this video right now and it will not hurt my feelings. What was my Pythagorean circuit? Here it is. First of all, one person caught my mistake here. Well, I did make a mistake on one of this. I asked for power at resistor 4, and there was no resistor 4. I meant to ask for power total. Whether you answered that or not, you were good. I did not put the little symbol on this to make sure that everybody knew that it was a right triangle. But I think I said it's Pythagorean. Most of you assumed it was. I had 37 of some unit, happened to be miles on this one. I had 102 of some unit on this, and I said solve for C. So on this one, what I need to do in my calculator, because the formula is C equals the square root of A squared plus B squared. In this case, I'm going to make that A and that B, but it doesn't matter which is A and which is B. So I'm going to say C equals the square root of. Now the square root is just something you dump into your calculator. The square root says, what number times itself equals the number that I'm asking about? So the square root of 16 is 4. The square root of 25 is 5. The square root of 144 is 12. I mean, so these are numbers that most of you probably already know. A number times itself is the number square. So 2 times 2 is 4. 2's square is 4. 4's square root is 2. 4's square is 16. 16's square root is 4. I'm hoping you guys have that already. So, square root of these numbers. I'm going to say square root of 37 squared plus 102 squared. If I dump that through my calculator, I'm going to go 37x to the 2 plus 102x to the 2. Enter. And then I'm going to go second square root symbol, second answer. Or I might just be able to go second square root, enter. We'll see, I think it dumps this last answer in automatically, but I'm not sure. Second square root, second answer, enter, and it will give you, in this case, I think it was 108.5, and our unit was miles, M-I-L-E-S. Kind of space that out, mules, 105 mules. Now, 108.5 miles. If you answered 108 or 109 or something in there, I gave you credit for it. Because what's a half a mile when you're walking 108? So that is the Pythagorean. That is this video. I am going to make another video right now that if you are watching this, you still need to watch. And that is the video for continuing on into AC this next term. It's the entrance to AC.